Hey guys, it's been quite a while since I made my last video. So anyways, I'm back with plan to make like at least one video a week. I'll see how that goes. So let's continue. And if I'm going too fast, then you can pause and watch it again. And if I'm going too slow, then you can use the YouTube feature to forward it or play it faster. So let's get into this topic. In my last video, I talked about when different types of motion, and whenever there's motion, there are certain terms that are involved, like distance, displacement, velocity, speed, acceleration. I kind of introduced these terms to you. You can watch that video. I'll put a link in the description below. You can watch that video and understand the differences between these terms and understand that these terms come up when there is motion involved. And among different types of motions, there are like various types of motions, and we are studying linear motion for now. And also, linear motion is basically motion in a straight line, so it's pretty straightforward to understand. And also in linear motion, we will be specifically studying about two types of linear motion. The first type is linear motion with constant speed, or let's say constant velocity, and the second type is linear motion with constant acceleration. So these are the two types of linear motions that we have to study as per your syllabus. So constant speed, it means acceleration is zero. So because acceleration is rate of change of velocity, and if the velocity is constant, it means acceleration is zero. And here acceleration is constant, which is some constant, so acceleration is not changing in these types of motions. So now let's look into linear motion with constant speed. So in linear motion with constant speed or constant velocity, we only have like one formula, which is velocity v, or you can write it as u, equals displacement over time, or we can write it as s equals vt. Some people may write it as s equals ut, where u denotes velocity and t denotes time taken after this side of the motion. So in this video, what I'm going to do is show you how to make ST graphs, how to make VT graphs, and these understanding like how this graph work, understanding how to make these graphs is really important to proceed further. So let's have some kind of case study. Let's say it is a straight road, and there is a guy who starts at this point A and travels in a straight line at a constant speed of 5 meters per second. So it means that after 1 second he has traveled 5 meters, and in the next second he travels 5 meters, and in the next second he travels 5 meters. So that's the meaning of like having a velocity of 5 meters per second, means like the man travels 5 meters in every second. I want to plot a graph of velocity on my y-axis and time on my x-axis when t equals 0. So he started from this point, so this is the point where he started, so it basically means when like time started from here, so time is 0. So when time was 0, his velocity was 5 meters per second, right? This is y-axis, and when time was 0, his velocity was 5 meters per second. After 1 second, since his velocity is constant, he's gonna have 5 meters per second, and when time is 2 seconds, his velocity is constant, so it's gonna be 5 meters per second. So if I plot all these points, then you can see that I will get a straight line. So it's a very simple graph. So the VT graph for an object moving in linear motion at constant speed is basically a straight line. And if I try to plot a graph of ST graph, so let's say I have 5, 10, 15, oh sorry, it's like 1, 2, 3, 4, and then let's say 5, 10, 15, something like this. So when t equals 0, so I'm measuring his displacement or distance. I'm measuring his displacement from this point. When he was starting, his displacement was 0. So when t equals 0, his displacement was 0. After 1 second, he has traveled 5 meters. After 1 second, he has traveled 5 meters. And after 2 seconds, he has traveled 10 meters. And if you see, and if I continue this pattern, then I'm going to fill these points up here. So if I connect all these dots, then I'm going to get a straight line. But it's not a straight line parallel to x-axis, but rather it has a slope. And now let's look into mathematics of this and why is it important to draw this graph. So we know the formula for v velocity is v equals s by t, or s equals vt. So we know s equals v times t, right? Now from your high school algebra or high school mathematics, you know y equals mx plus c. So this is the equation of a straight line. And you can say that here in my y-axis I have s, which is displacement, and in my x-axis I have t, which is time, and my y-intercept is 0. So you can see that the slope of this line m gives p. So slope of this line is equal to velocity v. So this is like a really fundamental thing that you need to understand. Like if I have a st graph, then the slope of this line will give the velocity of an object. And if I want to represent this relation in terms of calculus, then I would write v equals ds by dt. This basically means that velocity of an object, or let's say instantaneous velocity of an object, can be calculated from the graph of st graph, where the slope or the derivative of displacement over time is equal to v. And it's basically from this formula equals s by t. I hope it's clear up to this point. So if we have a st graph, and if we calculate the slope of the line, of the curve or line at any time, then what you get is the velocity of an object at that point in time. Now let's say I have vt graph, and something interesting happens here. So if I look at the formula for displacement, s equals v times t, right? And from your high school, you know the area of a rectangle is length into breadth, right? So let's say if I have a rectangle here and it has length L and breadth B, so the area is L into B. And so this is the graph of vt graph that I plotted from the motion of this guy in his straight line. And if I think about this formula, S is equal to v times t. So if I look at this formula, then my velocity v is a y-axis, and the time t is a x-axis. So if I want to find the distance he has traveled, so it's going to be, let's say if I want to find the distance he has traveled in the first second, which is 5 meters, right? So if I want to find his displacement in first second, I multiply by his velocity and the time it took. So in 1 second, it's going to be 5. And that's basically what I'm doing here, is like finding the area of this graph. So if you think about it, the area under the curve of velocity time graph gives me displacement. See, so if I want to find his velocity, let's say after 3 seconds, then what I'm going to do is like draw a line here, and then the magnitude of the area of this graph, area under this curve, gives me the displacement of the boy after 3 seconds. So if I calculate the area, the height is 5, and if I calculate this thing, this is 3, so it's basically 5 times 3, which is basically simple thing. Like if we use the formula, we're also going to get s equals ut. His speed is 5, and if I want to find his distance traveled after 3 seconds, I multiply with 3. So you see, it's a very subtle thing, but it's really important to understand. Like if I have vt graph, area under the graph gives me the displacement traveled. So let me summarize what you've learned up to this point. So if I have a st graph, then velocity is the slope of the graph, and if I have vt graph, then displacement is the area under the graph, and this is the symbol for integration from calculus. So to recap, if I have a vt graph, let's say some kind of graph, then the area under the graph gives me displacement. So displacement is the area under the vt graph. And if I have a st graph, then the slope of this graph gives me velocity. So these are the two fundamental things that you have to understand for now. And in the next video, we'll talk about acceleration and introduce the rate of, and introduce something more, and we'll proceed. So it's really important it's really important to understand how these graphs work and why these graphs work, because in the future I will not be explaining why these graphs work, and I'll just use the graph, and then you have to understand like why it's working. So I have a question here, and I'm going to solve some questions in this video, and these are all the questions from past paper of CIE A-level examination. So it says that a car accelerates uniformly from velocity v to time. So what we have is like vt graphs. So we have a vt graph, And the question asks on the graph which area the distance traveled by car in time t. So which area gives the distance traveled by the car in time t. So what we already know is that if you have velocity, if you have vt graph, then the area under the vt graph is the displacement of an object. And since the curve is here and time t is here, so this whole area, so the area that I marked here, this whole area is the displacement of the object. Option A says NPTU plus, so it's plus PQST, PQST. So option is basically saying that this whole area is the displacement, which is wrong. And option B says NPWV, so you can see V is here, NPWV, this area. And then VRSU, which is this area. And if you think about it, this is the answer, because we know the answer is this area, right? And NPWV is this area here, from here to here, and VRSU is this area from here to here. So what I need to show is that this area is equal to this area, and which is pretty forward to show because these two triangles are exactly similar. Some triangles are similar triangles and they have like exactly the same area. So I'm going to put B. So it says that ball travels from point X to point Y around a semicircular track of radius 1 meter. So it's traveling at semicircular track of length 1 meter. What is the displacement of ball from X to Y? So to find a displacement, of an object, all we need to know is its final position and its initial position, and then find the distance between these two. So since the question asks us to find displacement from point X to Y, point X is the initial position and point Y is the final position, I need to figure out the distance between these 2 points. And since the radius is 1 meter, so this is also a radius, right? This is radius 1 meter and this is the radius 1 meter. So the distance between X and Y is 2 meters. But the important thing is, since displacement is a vector quantity, it has direction. So its initial position was here and its final position is here. So you can see the direction is in this direction, right? So all we care about is its initial position and final position. So the direction is this, downwards, which is due south, and magnitude is 2 meters. So answer B. I put here with me a fairly difficult problem, but let's see. The graph shows how the velocity v of an object moving in a straight line varies with time t from t to t. So I have vt graph here, and vt graph is not a straight line here. The graph is changing with time t, and I need to find st graph. So what we know is that area under vt graph gives the displacement of an object. And to really understand what's going on with this graph, let me draw a diagram. So let's say an object is here, and let's say I take this direction as positive direction. So what you can see is initially the object is at rest, and so the displacement is 0, and the object is traveling at higher speed, and then it reaches its maximum speed, and then it slows down because, as you can see, initial velocity is 0, and then it increases, and then it decreases, and then velocity becomes 0. So, but still, velocity is positive, so the displacement is something like this. And then, since the velocity is 0, then the displacement, since the velocity is 0, it means that the object came at rest. And now what happens is, since in y direction the velocity is negative, it means we're taking this direction as positive. And since the velocity is negative, it means that the object is moving backwards. So what happens is, it starts moving backwards. And it starts moving backwards, and its increasing magnitude is increasing, and then it reaches some peak magnitude, and then it comes to rest. Let's say we don't know where it came to rest. So what we also know is that area under the graph is given, the area under vt graph gives displacement. So what I can see here is that this area is equal to this area. So what I can say is that he travels same amount of displacement during this time as he traveled in this time. So he started from this point, reached this point, and then he came back exactly at this point. So the total displacement was 0. And we can see that in all of these graphs, the total displacement was 0, right? So we cannot rule any one out yet. Since I'm taking this direction positive, his displacement was never negative. His displacement is positive, 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 positive. His displacement was negative. To have his displacement negative, he should have traveled in this direction, or he should have reached this. So then he would have negative displacement. So since he cannot have negative displacement, I'm going to rule out B. We can easily rule out C and D because they show that when he traveled half of his trip, it says that his displacement was 0. But his displacement was 0 only in the beginning and in the end. So we can easily rule out D and C, and the answer is A. So you can see that initially his displacement was 0, and then he went to some place and reached the farthest distance, and then when his velocity started becoming negative, so it means he started coming back. So it's like 9, 8, 7 or something like that. He reached 9, and then he traveled 8, which means he's coming back, and then at this point his displacement is 0. So you can see that this graph here is the accurate representation of ST graph which can be derived from this VG graph. And to check if this is really your answer, what you can do is like check some tangents. So you can see that at this point, so when there is a minimum or a maximum, the slope of the tangent at this curve is 0, right? So the slope of the tangent at this point is 0. So it means that velocity of ST graph at this point is 0, and you can see that the velocity is 0. And also you can see that at this point the slope looks really high. So at this point the velocity is maximum, and as you can see at this point the velocity is maximum, and at this point you can also see that the velocity is maximum and the velocity is maximum, but you can see the slope is positive here and the slope is negative here, and from here to here the slope is negative. You can check. So if you have slopes in this direction, this is positive slope, and if you have slopes in this direction, this is negative slope, and you can see that the slopes are negative and the velocity is negative from here to here. And again, to understand these concepts, I recommend you to watch a lecture on slopes and you really understand how to find slopes and how to relate slopes and stuff like that. Alright, that's it for today. We talked about displacement and velocity in a straight line with constant speed, which means acceleration is 0. And in the next video, we'll talk about AT graphs as well, where acceleration is non-zero, and we will see the connection between velocity and acceleration and more. And that's the next video.